Hello, it's me, Miss Billman, and we're going to talk about inequalities. This entire 7 minute and 25-second video will be looking at the four symbols, most used symbols in our case, and we will break down what an inequality is, what it looks like when you graph it, and so on. So I'm glad you're here. When you watch these videos, it means you're being an advocate for yourself, and you should be really proud of the work you're doing because you're putting in the extra time. So let's get to it. First, we need to talk about what an inequality is. Now, these are things you've seen before. Maybe you think like the alligator mouth is going to face the greater one. 2 is greater than 1. That's true. Absolutely. So they're not totally brand new, but maybe we're going to think about them in a different way. So when we see inequalities in the past, we've seen them really just using two different symbols. We're going to include two more. Sometimes you see a not equals to. You can use that one. Absolutely. Most of the time that will be used in an answer, not necessarily graphed, because that's pretty tough. Just like everything else we've done in math, it's like becoming fluent in another language, which sometimes it's hard to believe that you are doing that, but you really are, and you're totally handling it like a champ. So an inequality is a mathematical sentence that compares two quantities and includes symbols. Normally going to be one, but there are some options that we have. And a mathematical sentence doesn't normally look like a regular sentence you would use in ELA or any other subject really, but that's okay. But what are the symbols that we're going to be looking at? And if you were asking that, I'm so glad you did, because I'm going to go over that in the next page. So great question. When we talk about reading in math, it does require some critical reading that you can use across the subject areas. And it's cool to use the strategies you use or learn from other classes in another class. And I think that's pretty cool. So to talk about the four different symbols in inequalities, saying the word in a lot, I'm going to make a graph. If you're in my class, we will be making this in our note catcher. It's a grid. It will have about 5 rows and 4 columns. The first column will be the word symbol. The second one will be meaning. The third one will be graph, because we look at graphing these. And then the fourth column will be examples. When we graph, we're actually looking at a number line, again, which is pulling back from what you've learned in the past. So we will start with the symbol that looks kind of like a Pac-Man or an alligator mouth. I'll go with either. And it means less than. With inequalities, we will be reading left to right. So I'm plugging less than in when I see that symbol. If I graph it, I find a circle, an empty circle on a number line, and I just put a dash in there so you know it was on a number. I'm going to grab another color, and my arrow will be going to the left. I'm going less than. It must be a smaller number. So if I had to write some examples, well, I can think of a lot, but if I had 3x is less than 6, that's one way you might see it. I could say 2 is less than 7. That's also true. X is less than 3. Those are examples of things you may see. The opposite of that would be greater than. If we're going to have less than, we're probably going to have greater than. So if we graph it and you're seeing a pattern, normally in math, if they're opposites, it's probably going to go the opposite direction. So I'm going to make a number line. I'm actually not going to number the number lines, but I have the dashes. I'm going to grab that red. I'm going to find a number. I put a circle, and my arrow goes to the right. It is greater than. The numbers are getting bigger for it. So if I write that as an example, I could write 63 is greater than 12. That's a fact. It is. It's greater than 12. 4x is greater than 2. Well, that's also true. So if we have less than or greater than, what happens if we include equal to? So the pink one is less than or equal to. You may see this in other ways when you're reading a real world situation. They're not necessarily going to say less than or equal to. They might say at most. So my house, I have 2 dogs and 2 cats. And I could say my house should have at most 4 animals. That's a lot of animals. When I graph this one, I will have a circle and it'll be filled in. It's still going to go to the left, but the circle is different. It's filled in. It's saying, hey, this is a number we could keep. Like I said, when I'm having 4 pets, I should have at most 4. So 4 or less than. Now I could write 2x is less than or equal to 16. So, I mean, x could be 8, and that's equal to. X is less than 7. Same thing. I could do that. I could say the number 7. I could say the number 6. And, of course, the opposite of that would be greater than. And when I see greater than, I will have some clues in the words. Again, we're bringing those critical readers, going back through and reading the problem more than once. There's absolutely nothing wrong with that. So I may see it as at least. That's a pretty common way to hear or read it. I want to have at least 800 years of teaching. I mean, wow, I'd have to be a ghost, but it works. My circle would be filled, and my arrow will go to the right. If I were to write an example of this, I could say 33 is greater than or equal to 33. Well, that's exactly right. I mean, 33 is equal to 33. 14 is greater than or equal to 2. I mean, also true. I could even say 14 is greater than or equal to 2x. Remember, inequalities take some time, so attend to precision. You got this.